So this is a hydraulic crusher machine. So what happened here is that vandals came, cut off all the electrical connections. This one I just ran this one new. This is for a door switch. Vandals came and cut off many parts of the machine. They removed the entire electrical components. All these ones were just introduced. There was nothing inside when I came here. They also removed the hydraulic pump that supplies hydraulic pressure to the piston. So everything electrical was removed. So now, in order to bring this very machine back to life, I had to run fresh wirings to the system. So here, this is the door of the hydraulic crusher. This is the hydraulic ram that comes in and will crush whatever is put here. It could be a metal drum, it could be items you want to press into a bale. So this door switch has a sensor here. This sensor goes into this hole here to activate this switch. So if you watch, as this one goes down, it will enter inside the hole to activate the door switch. So previously, the machine had timers, a transformer, and other components that it ran. It was a manual operation. So in order for it to run easier, I introduced a small Mitsubishi PLC. This is the FX3SA PLC. So the total running system we have here, we have two push buttons, one to activate the system and one to shut off the system. So normally, though I was not here when the machine was operating, based on the knowledge I have or based on the experience I've had, I believe once you push this button, the RAM will activate, go, crush, stop, delay for like a few seconds, then return back to the original position. And this one is to, in case maybe there's an emergency or there's an issue, you can push this to stop it. But I believe once you stop it, it has to go back to the original position. So I'm going to run a program on this PLC so that once I push this button, I get a signal to my PLC to start the system. So I'm going to push, stop, delay, then return. So in order to do that, I have to have limit switches. So the limit switch I'm going to introduce here. First of all, there are already limit switches. I noticed that if I look inside here, though you won't see it clearly from camera, there's one limit switch there. I'm sure that limit switch is to tell us the end of the RAM when coming back. But going forward, there was no limit switch, but I noticed a pressure switch. So what I understand is that as it's pushing, it's going to exert so much force on that end that this pressure switch is going to activate. So this pressure switch is what we're going to use as the limit on that end. So this pressure switch will be the one to trigger it that you have pushed too much, stop. So I'm going to give signal from this pressure switch down to my PLC also. So we have our end limit for pushing back, and we have this to activate the limit pushing forward. Then finally, our last input, no, not the last input, our third input is going to be the door switch. This thing is not going to run for whatever reason if this door is open. So I'm going to take a signal from the door switch also as an input to my PLC. So then the final two inputs will be these two push buttons, this and this. So what I did is that I brought in a single common, that is 3 wires here. I brought in a single common, then one of the wires as a common with this to give me a signal there, another common with this to give me a signal here. So, though I've already put everything together, here is my PLC. So these are my inputs. So considering that I want to use an NPN system, I want to use an NPN system. Majorly I use NPN systems, except otherwise where I encounter sensors that are PNP. So if you understand NPN, neutral, positive, neutral, or negative, positive, negative, it just means that our negative is our signal. You understand? So in order to do that, here You see, if you look at this PLC, you see 24 volts and 0 volts. Very important. So this 24 and 0 volt is going to be what we use for our input. So since I want to use negative as my input, I'm going to pick this 24 volts, loop it into SS here. So SS will serve as basically our just 24 volts to SS. If I wanted to use positive, I'll take 0 volts to SS. So since I've taken my 24 volt to SS, then 0 volts, which is 0 V here, will be my common. Will be the common for the switches, will be the common for the door switch, will be the common for the limit switch, and will be the common for the pressure switch. So basically I've done that here already. I labeled it down on my booklet. When I'm done, I'm going to label everything properly. So I've labeled it down on my booklet. So S 0 volts is my common, then that's that. So I now have 3 relays here. Generally, I have 3 outputs that I need to operate. 3 outputs. So I used Y0, Y1, and Y2. So Y0 will be for the motor, which is the electric motor that will run the hydraulic. So Y0, I used Y0 to power this relay. Then I use Y1 to power this relay, then I use Y2 to power this relay. Y1 will be our push signal, and Y2 will be our open signal. So Y0, on the other hand, is going to power my contactor here. This contactor will power my motor. No, I could use the PLC to power the contactor direct. It's very possible, but imagine there's an issue with the coil and I end up damaging my PLC. PLCs are expensive. So I'd rather my contactor damages the relay than damaging my PLC. Relay is cheap. I can just pull this one out and replace it with a new one. So it's cheaper for me to replace a bad relay than to replace a PLC. The whole process is hectic. So basically that's what I did here. So this is my motor breaker. My power supply goes to the main switch on the door. So I powered my breaker to my contactor, then my contactor to the motor. I put 2 fuses here to protect my system here. So forget the 32 amps you're seeing here. It's actually a 2 amps fuse that's inside. So that way I have protection on my system. So now my Y1 and Y2, remember, though I'll show you the code I'm going to use. The code I'm going to use here, once the button is pushed, the motor will be the first thing to start. So once the motor starts, there will be a slight delay, then Y1 will come on. Y1, we activate one of these coils. I'm still here to determine which one is for push function, but I'll test before I finish. So my push signal will power one of these relays. My return signal will power one of these relays. So that's basically what I've done here. I assembled this, I put this motor, the hydraulic unit, due to the difference in the design of the motor, my suction pipe did not match exactly. So what I'm going to do here, I'm going to go to the market, get an elbow, put here another elbow here. I'm going to thread this metal pipe so that I can connect. That will be the finishing to this connection. So that's that for this crushing machine. At least with this system, we can get this machine back in operation. So what's left is, after I finish my wiring, supply power, I'm going to download the code which I have programmed into this PLC. So once the code is in the PLC, then our system is operational. Thank you.